S. So we'll continue solving problems on chart bits method. So I'll quickly recall the chart bits method, right? So I'll quickly recall the chart bits method. So there will be one question. It is not necessary that P and Q are linear, right? So it can be non-linear also. That is, we can also have P square, Q square. It can be anything. So first you have to write f of f is equal to, you have to bring all the terms to this side and equate this to 0. You call this equation as 1, right? This is the first step. Now you have to find chart bits auxiliary equation, right? You know that the equation, you have to find that equation. So from this equation you have to find P or Q, right? You can find either P or Q. So if you look at this equation, if you see which is easy, finding P is easy or finding Q is easy. So after finding P or Q, suppose if you have found P, substitute this in 1 to get Q, right? Substitute this in 1 to get Q. Suppose if you have found Q, substitute in 1 to get P, right? To get P. So after finding P and Q, so P and Q has to be a function of, P should not contain Q, right? It can be a function of x, y, z and constant terms. It should not contain Q, and similarly Q should not contain P in it, right? It can be a function of x, y, z, a, etc. right? So in finding P, it should not contain Q, and finding Q, it should not contain P. So after finding auxiliary equation, you can either find P or Q and substitute in 1 to get another value, and change P and Q to in terms of x, y, z, q, and then you have to substitute in this formula dz is equal to P dx plus Q dy, and you have to integrate this to get the complete integral, right? So this is the procedure. So we'll move on to the first problem, third problem overall. So third problem, this question asked in 1997, right? 1997. Actually fourth problem overall. So z into p square z square plus q square equal to 1. So this is question asked in 1997, right? Z square, p square plus z square. Yes. So first you have to bring all the terms this side. So our f will be, if I multiply z square inside, I will have p square z power 4 plus z square p square minus 1 equal to 0. This is the first step, right? And second step is we have to find chart bits auxiliary equation. So what is our chart bits auxiliary equation? So it is dp divided by fx plus pfz is equal to dq divided by fy plus qfz is equal to dz divided by minus pfp minus qfq is equal to dx divided by minus fp dy divided by minus fq, right? First you have to find this auxiliary equation. So what is our f? F is p square z power 4. Now we will find fx, fy, fz, fp and fq, right? So what is our fx? So differentiate this with respect to x, partial differentiate with respect to x, so it will be 0 because it has no 0. Fy will also be 0 because there is no y term here. So what is our fz? So p square, if we differentiate z power 4, we will have 4z cube, and here we will have p square into 2z, right? P square into 2z. And what will be our fp? So z power 4 will be constant, so p square will be 2p plus z square will be constant, so again it will be 2p. What will be our f cube? It is also equal to 0. So what will be our auxiliary equation? So it is dp divided by fx plus pfz. So fx is 0, p into fz. So fz is p square into 4z cube plus z square q square, right? Z square q square. So z square q square. So fy will be 0 and fz will be p square will be constant. So z square, z power 4 will be 4z cube and q square will be constant. So z square will be 2z. Now fp, so fp will be z power 4 will be constant. So we have 2p and fq, z square will be constant. Here we have 2q, right? So when you substitute here, we will have fx. So fx is 0 plus p into fz. So p into fz. So what is our fz? So fz is 4p square z cube, 4p square z cube plus 2q square z plus 2q square z is equal to dq divided by fy. Fy is also 0 plus q into fz. So fz is again 4p square z cube plus 2q square z is equal to dz divided by minus p fp. So minus p into fp. So fp is 2p z power 4, 2p z power 4 minus q into fq. So fq is 2z square cube, 2z square cube. This is equal to dx divided by minus fp. So minus fp is minus 2p z power 4 dy divided by minus fq. So minus fq is minus 2q z square. So this is our auxiliary equation. Now you need to find p or q, right? Now from consider the first two fraction, right? Consider the first two fraction. So if you consider these first two fraction, you can see if I take these two fractions, this term and this term will get cancelled, right? If I equate only first two terms. So what we have left with is dp by p is equal to dq by q, right? So this term will get cancelled. So we have dp by p is equal to dq by q. So when I integrate this, we will have log p. So integrating log p is equal to log q plus log a, or I can also write this as log p is equal to log aq, right? Log a plus log b, or p is equal to aq, right? So from this auxiliary equation you have to get either p or q. So I found p is equal to aq, right? Yes. Now we need to find the value of q. Remember, the value of p should be in terms of x, y, z, right? So this is not our p value. After that we have to redefine this. So first we have to find q. So substitute this value in equation 1. That is the procedure, right? So substitute p is equal to aq in equation number 1. So what is our equation number 1? Equation number 1 is p square z power 4 plus z square q square minus 1 is equal to 0. Now I'm going to substitute p is equal to aq here, and then I'm going to find q. So this will be aq whole square, right? P square into z power 4 plus z square q square is equal to 1. Now I can take q square z square common here, right? I can take q square z square common. If I take q square z square common here, so here we will have a z square and here we will have 1 equal to 1. So that means q square is equal to 1 by z square into a z square plus 1. So that means q is equal to 1 by z into a z square plus 1 whole power 1 by 2. This is our value of q. So q is correct, right? Because you can see q does not contain p. Therefore q is right answer. Now we want to change p is aq here. Now we substitute q is equal to 1 by z into a z square plus 1 by 2, we will get p, right? So we will mark this as 1, so we will mark this as 2, we will mark this as 3. Now substitute 3 into, right? Substitute 3 into, you will get p and you will get q, right? So here p is a q, p has to be a function, p should not contain q, say, so therefore we have to replace q by this term. So if we replace q by this term, we will have, so 2 becomes, so what is our p? P is equal to aq, so our q is 1 by z into a z square plus 1 whole power 1 by 2. So we have found p and q. Now what is the last step? dz is equal to p dx plus q dy. Now we have to substitute p and q and then we have to integrate to get the required answer. Now we substitute here, we will have dz is equal to, what is our p? P is a by z into a z square plus 1 whole power 1 by 2, and q is 1 by z into a z square plus 1 whole power 1 by 2 into dy, right? Now I can take 1 by a z square plus 1 whole power 1 by 2 outside. So if I take 1 by a z square plus 1 whole power 1 by 2 outside, you will have 1 by z into a z square plus outside, we will have a dx plus dy, right? Now if I bring this to this side, if I bring this term to this side, we will have z into a z square plus 1 whole power 1 by 2 dz is equal to a dx plus dy. Now we have to integrate this, right? Now what I am going to do is, so we have to integrate this. So before integrating this is very easy. This will be ax plus y. Now here we need to use substitution. So I am going to put t square is equal to a z square plus 1. So this will be 2t dt by dz. By differentiate with respect to z, so here you will have 2az, right? 2az. So t is equal to a square, sorry, a square, right? A square z power 4, sorry, a square, because a square q square, right? If I take q square outside, we will have a square z square. This will be a square, this will be a square. So I can write this term to be, so 2t dt by dz is equal to 2a square z plus 0, right? Now I can cancel yes, now I can cancel 2 and 2, so we have t into dt is equal to a square z dz. Now I can replace dz to be z into dz, I can replace z into dz to be t by a square dt, right? T by a square dt. Now this becomes, so let us mark this equation to be equal to 4. Now this becomes, I can replace z dz to be, so first we integrate this, right? So let's integrate this. So I can replace z dz to be t by a square dt, and this is our t square, right? Put t square is equal to a square z square plus 1. So this will be t square whole power 1 by 2, t square whole power 1 by 2. Z dz I can replace that by t by a square dt, and this is very easy, right? Ax plus y plus some constant b. So we have ax plus y plus some constant b. So These two will get cancelled. So we have 1 by a square integral t square dt is equal to ax plus y plus b. So when I integrate this, we will have 1 by a square and this will be t cube by 3 is equal to ax plus by plus some ax plus y plus some constant c, right? Ax plus y plus some constant c. Now you can replace again t to be equal to a square z square plus 1, right? So again you replace t to be equal to, so this implies t is equal to a square z square plus 1 whole power 1 by 2. Now you replace t to be equal to a square z square whole power 1 by 2. This will be 1 by a square. So I am replacing this to be a square z square plus 1 whole power 3 by 2, because we have 3 here, divided by 3 is equal to ax plus y plus c. This is the complete integral, right? This is a complete integral we need to find. That's it. So we'll move on to the next problem. So only thing is you have to find p from the auxiliary equation, and then you have to substitute in equation 1 to find the value of q. Now you change p and q in terms of x, y, z, a, and then substitute here and then integrate it. That's it. Second problem. So px plus qy is equal to pq. So overall is the fourth problem, and this question is all the question I am doing all are p by q. So fourth problem is fifth problem. Px plus qy is equal to pq, right? This is, I forgot the year, but this is in p by q. So first you have to write f. So what is our f here? Px plus qy minus pq is equal to 0. This is our f. Now what is our Char-Pitts auxiliary equation? It is dp divided by fx plus pfz is equal to dq divided by fy plus qfz is equal to dz divided by minus pfp minus qfq is equal to dx divided by minus fp dy divided by minus fq. Now we will find fx, fy, fz, fp, fq, right? So fx, what is our fx? Differentiate this with respect to x, so we will have only p. What will be fy? Differentiate this with respect to y, we will have only q. What will be our fz? Our fz is 0, right? Fz is 0. And fp will be x minus q, right? This will be x and this will be minus q, and fq will be y minus p. Now what will be our auxiliary equation? It is dp divided by fx. So p plus p into fz is 0, and tq divided by fy. So fy is q plus q into fz is 0. And here we have dz divided by minus p into fp. So fp is f minus q and fq is y minus p is equal to dx divided by minus fp. So we have minus x minus q and dy divided by minus y minus p. Now consider these two fractions, right? So from these two fractions we have dp by p is equal to dq by q, right? Same as previous problem. So when I integrate this, you will have p is equal to aq, right? This is what you did in the previous problem also. This will be log p and this will be log q plus a. So log q plus a, I can write this as log aq, and log p is equal to log aq means p is equal to aq. Now we need to find the value of q, right? Same as previous problem. Now substitute this, you will call this as 2, you will call this as 1. So substitute in 1 to get q, So what is our first equation? Px plus qy minus pq equal to 0. So what is our p? Our p is aqx plus qy and our P is AQ into Q equal to 0. Now I need to find the value of Q from here. So AQX plus QY, this I can write this as AQ square. If I take Q common here, I can cancel Q on 1Q here. So we have AX plus Y is equal to AQ, right? If I take Q common here and if I cancel 1Q with this, so we have AX plus Y is equal to AQ. So this implies Q is equal to AX plus Y divided by A. This is our Q. Now we need to substitute Q here because P has to be P should not be a function of Q. So if I substitute P, Q is equal to AX plus Y divided by A. So what will be my P? Now 2 becomes our P is equal to AQ. So A into Q is AX plus Y divided by A. We cancel these two A. So we have AX plus Y. So we have found P and Q. Now we need to substitute the value of P and Q in dz is equal to P dx plus Qy. So dz is equal to P into dx plus Q into dy. So dz is equal to, what is our P? It is Ax plus y dx and our Q is Ax plus y by A dy, right? Ax plus y by A dy. Now if I take Ax plus y outside, I can write this as dx plus dy by A and this will be dz. Now if I bring A, if I take LCM of A, so we have A into dz is equal to Ax plus y A dx plus dy, right? I am just taking LCM. So A dx plus dy by A and I am bringing this A to here. So we will have A dz is equal to Ax plus y. Now I can write this as A into dz is equal to Ax plus y. Now I can write this as d of Ax plus y, right? Because when I differentiate this, we have A dx plus dy. So I can write this term to be d of Ax plus y. So we have to make one substitution. So put u is equal to Ax plus y. You have to be strong in differentiation, then only you can do this. So this will be A dz, this will be u du, right? This is u and this is du. So when I integrate this, this will be Az and this will be u square by 2 plus some constant. So this is our complete integral. Now we can also replace u to be Ax plus y. So we have Az is equal to u square. So Ax plus y whole square divided by 2 plus b. This is our complete integral. So now we move on to the next problem. Our next problem is 1994. So third problem, this problem is asked in 1994. 16p square z square plus 9q square z square plus 4z square minus 4 is equal to 0. So 1994. So find the complete integral, right? So every question, the question is find the complete integral. So again, so first we will bring, already it is in the right format, right? So this is our f. This is our f because every term is here and is equal to 0. Now we will find auxiliary equation. So it is dp divided by fx plus pfx pfz is equal to dq divided by fy plus qfz is equal to and here we are going to have dz divided by minus p minus qfq and dx divided by minus fp dy divided by minus fq. So first you will find fx, fy, fz, fp and fq. So what is our fx? We need to differentiate this with respect to x. So there is no fx and there is no fy also. So what will be our fz? So fz will be, so we will differentiate this term with respect to z. So 16p square will be common, so this will be 2z, and 9q square will be common, again this will be 2z, and here we have 4 into 2z. And fp, so fp will be 16z square will be common, so we have 2p, and here 9z square will be common, here we have 2q. So this becomes, so this auxiliary equation becomes, so consider I am going to take only the first two fraction, right? So you can substitute, but I am going to take only first two fraction. So we take only the first two fraction, and since fx is 0, fy is 0, automatically this fz and this fz will get cancelled, because this fy is 0, this fx is 0. So what we have left with is dp by p is equal to dq by q. So 90% of problem we only have p is equal to aq as equation number 2, because already we have seen 3 problems, already all the problems which we did earlier, all the problems have p is equal to aq, right? So when I integrate this will be log p and this will be log q plus some constant a. So that means p is equal to aq. Same equation we are having, right? This is our 1, this is our 2. Now substitute this second equation in equation number 1 to find the value of q. So this will be 16p square. So in place of p square, I am going to write aq whole square into z square, 9q square z square. I'll take both these terms that side, so we will have 4 minus 4z square. So we have 16a square q square z square, 9q square z square is equal to, if I take 4 common, you will have 1 minus z square. Now what I can take a common here is, I can take q square z square common. So if I take q square z square common, so we have 16a square plus 9 is equal to 4 into 1 minus z square. So this means q square is equal to 4 into 1 minus z square divided by z square into 16a square plus 9. So that means q will be, by take square root, so 2 into 1 minus z square whole power 1 by 2 divided by, so this will become z and this will become 16a square plus 9 whole power 1 by 2. So I am just taking square root. If I take square root, 4 will be 2, z square will be z, and here this will be 1 by 2, this will be 1 by 2. So q is 2 into 1 minus z square whole power 1 by 2 is. Now what will be our p? Now 2 becomes, so and since p is equal to aq, so I am substituting here, so we will have a into q. So q is 2 into 1 minus z square whole power 1 by 2 z into 16a square plus 9 whole power 1 by 2. So this is our value of p. Now we will substitute the value of p and q in. So substitute the value of p. So what will be the dz is equal to p into dx plus q into dy. So this will be dz is equal to, so p, what is our p? Our p is a into 2 into 1 minus z square whole power 1 by 2 divided by z into 16a square plus 9 whole power 1 by 2 plus q. Q is 2 into 1 minus z square whole power 1 by 2 divided by 16a square plus 9 whole power 1 by 2 into dy. Now I can take this entire term common here. Now I can take this term common. So if I take this term common, we will have 2 into 1 minus z square whole power 1 by 2 into, and z into 16a square plus 9 whole power 1 by 2. If I take this term common, so here we are going to have a dx plus dy. So here we are going to have dz, right? Yes. So if I bring this term to this side, we will have z into 16a square plus 9 whole power 1 by 2, and if I bring this term to down, so we will have 2 into 1 minus z square whole power 1 by 2 into dz is equal to a dx plus dy. This we can easily integrate. If we integrate this, we will have ax plus y. So this we have to make some substitution. So what I'm going to do is, so before that, what I will do, I'll bring this term to numerator. So we will have z into 16a square plus 9 whole power 1 by 2, and if I bring this term to numerator, so I'll keep 1 by 2 outside, and this will be 1 minus z square whole power minus 1 by 2 dz, and this will be a dx plus dy. Now I'm going to make substitution. Put t is equal to 1 minus z square, right? Put t is equal to 1 minus z square. So what will be my dt by dz? It is minus 2z. That means dt is equal to minus 2z dz. So I can replace dt to be minus 2z dz. Now we can see we have z dz, right? We have z dz, but I don't have minus 2 here. So for that, what I'm going to do is, I'm going to multiply minus 2 on both sides. So and then we will integrate this. So if I integrate this, what I will have? So if I integrate this, 1 by 2 is already there. So we have 16a square plus 9, and I'm going to name this as, we have already substituted that 1 minus z square is equal to t. So we have t power minus 1 by 2, and I'm going to multiply minus 2 to both sides, right? So I'm going to multiply minus 2 to both sides. So if I multiply minus 2, I can take these three terms, minus 2z dz. So I can replace minus 2z dz to be dt, right? So we have written this term, and I have written this term to be t power minus 1 by 2. Combining this term, we have written dt. So here we will have minus 2 integral a dx plus dy. So when I integrate these are all constants, right? Because 1 by 2 is constant, a is also constant. So I can take 1 by 2 16a square plus 9 outside, and if I integrate t power minus 1 by 2, so it is t power plus 1 by 2 by 1 by 2, right? Integration of t power minus 1 by 2, t power n plus 1 by n plus 1, and this will be minus 2 into ax plus y plus some integration constant b. So I can cancel this 2 and this 2. So what we have left with is 16a square plus 9 t power 1 by 2 is equal to minus 2 ax plus y plus b. This is our complete integral. Replace t again, right? So replace t is equal to 1 minus z square, then this is our complete integral. So we move on to the next problem. So this is sixth problem. Sixth problem is, this question is asked in 1999. 1999, p square plus q square 1991, and this question is 2xz minus px square minus 2qxy plus pq is equal to 0. Find the complete integral. The question is 2xz minus px square minus 2qxy plus pq is equal to 0. Now we need to find the auxiliary equation, right? So I straight away write the auxiliary equation, right? I'm not going to find auxiliary equation from now on, because fx, fy, fz, fp, fq, you can write that. So I'll straight away write the answer. So is it dp divided by 2z minus 2qy dq by 0, and here we have dx divided by x square minus q and dy 2xy minus p and dz divided by px square plus 2xyq minus 2pq. So this is our auxiliary equation. So from here you can see, from here we need to find p or q. In the last three problems we have written p, we have found p. Here you can see, since dq by 0, we have q is equal to some constant, right? So q is equal to a. Q is equal to a. Now substitute q is equal to a in equation number 1. We will find the value of p, right? So substitute q is equal to a in equation number 1, so that you will have to find p. So already q is not a function of p, so this is the final value for q. In the previous column we have p is equal to aq, that is the final value, because p contains q. So we have replaced q to be there, but here we don't need to replace. Q is equal to a is the final answer for q. So if we substitute q is equal to a in equation 1, so we have 2xz minus px square minus, so in place of q, 2axy plus p into a is equal to 0. We need to find the value of p. So what you can do is, we need to find the value of p, right? So we will keep this term as it is. So pa minus px square, and if we take this term to that side, so 2axy minus 2xz, 2axy minus 2xz. So if I take p common here, plus p cube, px square okay, both. So if I take p common here, we have a minus x square, and here I can take x common, right? If I take 2x common here, we have ay minus z. So what will be my value of p? Our value of p will be 2x into ay minus z divided by a minus x square. This is the value of p, right? Or else I can also replace this to be 2x into z minus ay divided by x square minus a. I just change this term and this term. If I change this term, we have minus here. If I change this term here, we have minus here. This minus will get cancelled. So if we have found q and we have found p. So what will be our dz? Dz is p dx plus q dy. So if I substitute here, so dz is equal to p into dx plus q into dy. So what is the value of p? P is 2x into z minus ay divided by x square minus a dx, and our q is nothing but a, right? So we have dz is equal to p dx plus q dy. Now what I can do is, so we will keep this term as it is. So we have to bring a z term, right? If I bring z term, so I can write this as dz minus a dy. So I am bringing this term to this side. So we will have 2x into z minus ay divided by x square minus a. So I can also bring Now I can also write this as dz minus a dy. If I bring z minus ay, we have z minus ay. So here we will have 2x divided by x square minus a. Now I can write this as d of z minus ay divided by z minus ay is equal to 2x divided by x square minus a. Now if I integrate this will be log z minus ay, right? Integral dx by x is log x. So in place of x we have z minus ay. This is nothing but log x square minus a, right? Log x square minus a, because when you differentiate this you have 2x in the numerator. So log x square minus a plus some constant log b, right? Or else I can also write this as z minus ay is equal to b into x square minus a. This is our complete integral. Move on to the next problem. Seventh problem. This question is asked in (2004, 2006). So important question, repeated question. P square x plus q square y is equal to z. So first, what will be our f? Our f is p square x plus q square y minus z is equal to 0. Now we have to write the auxiliary equation, right? So I will straight away write the auxiliary equation. So it is dp divided by minus p plus p square and dq divided by minus q plus q square and dz divided by minus 2 into p square x plus q square y dx divided by minus 2px dy divided by minus 2qy. Now you can see you cannot find p and q straight away from here, right? If you take this fraction and this fraction, you cannot find easily by method of grouping. The previous problem we have log a is equal to log b and then we have some denominator to be equal to 0, then we have it very easily. But here you can see method of grouping is not possible to find the value of p or to find the value of q, right? So what we need to do is we need to go for some other method. What I'm going to do is I'm going to multiply and divide by 2px with dp. I'm going to multiply 2px with dp and I'm going to add and I'm going to multiply p square with dx, right? I'm multiplying 2px with dp and multiplying p square with dx and then adding. So again I need to multiply 2px here, right? So 2px into minus p plus p square plus p square into minus 2px and I'm going to equate that to, I'm going to multiply 2qy to dq. So 2qy into dq and I'm going to multiply q square with dy and here I need to do the same. So 2qy and denominator of dq is minus q plus q square and I am multiplying q square with dy, so minus 2qy, right? Now we need to simplify this, right? We need to simplify this. So when I simplify this, what you will have? So this will be 2px dp plus p square dx and here we simplify this, here we have minus 2p cube x and this plus 2 cube will get cancelled, right? So this term and this term will get cancelled. So what we have is minus 2p square x. This is equal to 2qy into dq plus q square dy and again minus 2q cube by and plus 2q by will get cancelled. So we have minus 2q square y, right? Yes. Now I can write this term to be I can write the entire term to be p square x, right? Because when if I fix p square and you differentiate x, so we'll have p square dx plus x into 2px dx, right? So if I apply product rule to this term, you will get this numerator. So minus 2p square x. So I can also cancel this minus and minus, and here I can also write this as d of q square y, right? Q square y plus 2qy dq divided by q square y. Now we can see when I integrate this, this will be log p square x, and this will be log q square y plus some constant log a. So this means p square x is equal to q square y into a. P square x is equal to q square y into a, right? Yes. Now we need, this is not the final value for p because p contains q. So we will mark this as equation number 2. Now when you substitute this equation in equation number 1 to find the value of q, right? So if I substitute this in 1, so substitute 2 in 1. If I substitute 2 in 1, so this will be p square x. So in place of p square x, I can write q square ya, right? So this will be q square y into a. So in place of p square x, I have written q square ya plus q square y is equal to z, right? I have taken this term to that side. Now if I take q square outside, q square y outside, this will be a plus 1 equal to z. So that means q square is equal to z divided by y into a plus 1, right? Q square is equal to yes. Now what will be my value of q? So value of q will be z by y into a plus 1 whole power 1 by 2. This is the value of q. Now we need to find the value of p again, right? Because here p contains q. Now we need to find the value of p. Very important question. Now from 2 we have, in the previous column we have p is equal to aq, we simply substituted multiplied a, but here we have some other relation. So p square x is equal to q square y into a. Now I can substitute q square. So by q square will be, root will get cancelled. So we have p square x is equal to, so in place of q square, I can write z divided by y into a plus 1, right? And here we have ya. So this y and this y will get cancelled. So we have p square is equal to az divided by x into a plus 1, right? This x will get came here, and this means p is equal to az by x into a plus 1 whole power 1 by 2. So this is the value of p, this is the value of q. Now we will substitute in formula. So dz is equal to p dx plus q dy. So what is the value of p? Our p is az by x into 1 plus a whole power 1 by 2 dx plus, and our dy, so dy is z into y 1 plus a whole power 1 by 2 dy. So this is our dz, right? Yes. Now I am bringing dz to one side and dx dy to another side. So don't worry about this a by 1 plus a, that is just a constant. Now if I take z power 1 by 2, z power 1 by 2 common, and if I bring z power 1 by 2 to this side, so we will have z power minus 1 by 2 dz. So z power 1 by 2 I am taking common, and I am bringing z by 1 by 2 to this denominator. So if I bring this to numerator, we will have z power minus 1 by 2 dz. Here we are going to only have, here we will have, so a by Okay, what we will do is we will also bring 1 by 8. Okay, let me do this step by step. So I can write this as a power 1 by 2, z power 1 by 2, x power 1 by 2, 1 plus a whole power 1 by 2 dx, and I can write this as z power 1 by 2 by y power 1 by 2, 1 plus a y power 1 by 2 dy. Now I am taking z power 1 by 2 common and 1 plus a whole power 1 by 2 common. So if I take common this, so we will have z power 1 by 2 by 1 plus a whole power 1 by 2, and inside what we will have is root a dx, root a x power minus 1 by 2 dx, and here what you will have is y power minus 1 by 2 dy, right? So a power 1 by 2 is root a. If x power 1 by 2 become numerator, this will be x power minus 1 by 2, y power minus 1 by 2. I am bringing this term to this side, so we will have 1 plus a whole power 1 by 2, z power minus 1 by 2 dz. So this term to this side, this term to here, and then the numerator, and this will be root a x power minus 1 by 2 dx plus y power minus 1 by 2 dy. Now if I integrate this, so we integrate this, so if I integrate this, we will get the required answer. So this will be 1 plus a whole power 1 by 2, and integration of z power minus 1 by 2 is z power 1 by 2 by 1 by 2, and root a is constant, and this will be x power 1 by 2 by 1 by 2 plus y power 1 by 2 by 1 by 2, right, plus some constant, integration constant, plus b. I can also cancel this 1 by 2, 1 by 2, 1 by 2. So therefore this is the complete integral. So we move on to the next problem. So ninth problem. So ninth problem is asked in (2005), and this question is asked in IFS. It is not IAS, it is IFS. So the question is, question is 2z plus p square plus qy plus 2y square is equal to 0. So first I will straight away write the auxiliary equation, right? So the Charpit's auxiliary equation is dp divided by 0 plus 2p dq divided by q plus 4y plus 2q and dz divided by minus p into 2p minus qy dx divided by minus 2p dy divided by minus y. So we can easily find this, right? You just substitute in the formula. Just find fp, fq, fx, fy, fz and substitute in the formula. Now comparing this and this, right? I'm going to taking the first and fourth fraction. So we compare this, we will have dp by 2p is equal to dx by minus 2p. So these two will get cancelled. So we have dp is equal to minus dx. So when I integrate this, we will have p is equal to minus x plus some arbitrary constant. So this is the value of p now. Again, this is the final value for p because p does not contain q term. Or else I can also write this p term to be minus of x minus a. Minus of x minus a. This is the value of q. P. Now we have to find the value of q. So that we are substituting equation number 1. So this is our 2. So substitute 2 in 1. Substitute 2 in 1. So 2z plus p square. So if we square this, minus will get vanished. So we have x minus a whole square plus qy plus 2y square equal to 0. We need to find the value of q, right? So I'll keep qy here. I'll take all the term to this side. So we have minus of 2y square minus x minus a whole square minus 2z. So that means q is equal to minus of 2y square minus x minus a whole square minus 2z divided by y. So this is the value for q. Now we have found value of p and q. We need to substitute in dz is equal to p dx plus q dy. So when I substitute here, so we have dz is equal to p dx plus q dy. So dz is equal to, what is the value of p? So value of p is minus of x minus a dx plus q. So minus of q is minus 2y square, sorry, plus, right? I taken minus outside, plus. I taken minus outside and I am bringing other term to this side. So this will be minus of, we will write this as minus and q is 2y square plus x minus a whole square plus 2z divided by y into dy. So we need to integrate this term, right? Yes. Now what I'm going to do is I'm going to make one arrangement. So multiplying both sides by 2y square. I'm going to multiply both sides by 2y square. We'll quickly know why I'm doing this. So if we multiply both sides by minus 2y square, so this will be, sorry, plus 2y square dz, right? I multiply 2y square here, so we have 2y square dz, and here I am multiplying 2y square. So 2 minus 2 is already there, minus already there. So 2y square into x minus a dx, and again I am multiplying 2y square here. So if I multiply 2y square, this y and this 1y will get cancelled. So we have 2y here. So minus 2y into 2y square plus x minus a whole square plus 2z, right? Yes. Clear? So if I multiply 2y square here, 1y and 1y get cancelled, so we have 2y. Now this will be 2y square dz, and if I keep this term as it is, minus 2y square x minus a dx, and if I multiply 2y to all the term, so we will have minus 4y cube minus 2y into x minus a whole square minus 4yz, right? Minus 4yz. Now what I am going to do is I am going to combine this term and this term, this term and this term. So if I combine this term and this term, so 2y square dz, and I am bringing this term to this side, we will have plus 4yz, right? I combine this term and this term. I am going to combine this term and this term. So further what I am going to do is I am going to write this as, if I bring both the term to this side, so we have plus, if I bring both the term to this side, we have plus. I can write this entire term to be, okay, we will first write this. So 2y square x minus a dx plus 2y x minus a whole square, we have multiplied dy, right? So dy, and again we have to multiply, right? So 4y cube dy, this will be dy into dy, right? So I am bringing 4y, I am bringing this term to this side, so we will have plus 4y cube dy equal to 0, right? So I have taken this term to this side and I combine these two terms. I have taken these two terms to this side, I combine these two terms, and I have written this term separately. Now I can write this term to be d of, okay, let me take 2 outside here. If I take 2 common here, this 2 will go where, here will have 2, right? So I can write this term to be d of y square z, why? Because if I fix y square and then dz, so we have y square dz. and if I fix z, you will have 2y dy. So z 2y dy. So I can write this term to be like this, and I can write this term to be d of y square x minus a whole square, right? Because when I fix this, so we have y square, and if I differentiate this with respect to x, so we have 2x minus a dx, and here if I fix x minus a whole square, this will be 2y dy, and this term will remain alone, 4y cube dy. Now when I integrate this, this term we will have only 2y square z, that's it, right? Because differential integration will get cancelled, and when I integrate this, we will have y square x minus a whole square, and when I integrate this, we will have y power 4 by 4 equal to 0. I can also cancel 4, so therefore the complete integral is 2y square z plus y square x minus a whole square plus y power 4 equal to 0 is the complete integral for this question. I am going to solve another 2 more problems, and then the chart piece method will get completed. And then you have to practice more problems also, right? I will tell the page number, you have to practice some more problems also. So every method is same, right? First you have to write the auxiliary equation. You can either find, or we can either find p or q. So after finding p or q, substitute in the equation number 1 to find the other value, and substitute in dz is equal to p dx plus q dy, and then integrate, right? So this integration needs some practice, right? So 10th problem, px plus qy is equal to z into 1 plus pq whole power 1 by 2. This question is asked in 1992, and this equation, it's a very vague question, and this equation needs a bit of ODE also, right? So you will have some ODE at last. We have to solve that ODE to get the answer, right? So we have already solved one problem, like using integrating factor, we have solved one problem, right? Here you go and also solve using that, right? So px plus qy plus z into 1 plus pq is equal to z. Now we will bring all the terms to this side. So we will have px plus qy minus z into 1 plus pq whole power 1 by 2 equal to 0. Now you find the auxiliary equation, right? So fx, fy, fz, you can do this. Now what I am going to do is I am only going to take the first two fractions, that is dp and dq. If you take the first two fraction, what you will have is, when you take the first two fraction and then you will simplify, taking first two fraction, you will have dp by something, dq by something, dz by something, dx by something, dy by something. From that you take and then you simplify that. If we simplify this, we will have dp by p is equal to dq by q, right? So simplify this, right? So we simplify, we will have this. So from this we will have p is equal to aq, right? Because we already solved lot of problems, right? If we integrate this, we will have log p, this will be log q, right? So log p is equal to log q, that means p is plus log a, p is equal to aq. Now we need to find the value of q. So this is our equation number 1, this is our equation number 2. So substitute 2 in 1. So if I do this, you will have pq plus qy, is equal to z into 1 plus pq whole power 1 by 2. Now I need to substitute p is equal to aq. So p is equal to aq. So aqx plus qy z into 1 plus p is equal to aq into q whole power 1 by 2. And Yes. Now we need to find the value of q here, right? So we need to find the value of q. So if I take q common here, we will have ax plus y, and can write this term to be, I will keep this term as it is, 1 plus a q square whole power 1 by 2. Now I need to find the value of q, right? Because here you have 1 q, here you have 1 q. We need to combine that. So by squaring on both sides, we will have q square ax plus y whole square is equal to z square 1 plus aq square, right? Q square ax plus y os. Now what I can do is q square ax plus y whole square. Now if I bring this term to this side, so we will have minus z square aq square, right? Z square aq square multiplying and then bringing this side. Here we will have z square, right? Z square aq square, I am bringing this side. Now I can take q square common here. But take q square common, we will have ax plus y whole square minus, and here we will have a z square is equal to z square. So therefore our q square will be z square divided by ax plus y whole square minus az square. That means q is equal to z divided by ax plus y whole square minus az square whole power 1 by 2. So you have found p and q. So we need to substitute in dz is equal to p dx plus q dy. It's a very easy problem. The only thing is practice. And p is aq, right? P is equal to aq. So therefore we need to substitute q here. So a into z of ax plus y whole square minus az square whole power 1 by 2. Now what will be our dz? Dz is equal to p dx plus q dy. So p, our p is, now I can take this common, right? After substituting here, I can take this term common because this term both are common. So we take z by ax plus y whole square minus az square whole power 1 by 2. We take this common. So we have, so here we are going to have p dx. So we have a dx plus dy. A dx plus dy. After substituting p and q, I am taking z by ax plus y whole square minus az square whole power 1 by 2 common. Here we have dz. Here we have dz. Now, if I bring this term here, we will have dz by z is equal to dz by z is equal to a dx plus dy divided by ax plus y whole square minus az square whole power 1 by 2. Now we need to integrate this, right? So we need to make some substitution. So for that, what I am going to do is put a dx plus dy. Don't worry about this because if they asked a problem in Chapit's method, they will only ask the problem that are in Rising Enya book. I have already solved 10 to 12 problems. So still there are 10 problems you can practice in that book, right? So tell the page number, you practice all the problems, right? There will be no new question, only from that question also. So you remember how to solve these sums. That's it. So put a plus dx plus dy is equal to root a into du. So I am going to make a substitution. I am going to make some substitution. I am going to make ax plus y. I am going to make this ax plus y as root a into u, right? Root a into u. So if I differentiate this, we will have a dx plus dy is equal to root a du, right? Root a du. Now I can replace a dx dy by root a du. So this will be dz by z is equal to root a into du, a ds plus dy is root a into du, and this will be ax plus y is root a into u whole square minus az square, right, minus az square whole power 1 by 2. And this I can write this as dz by z is equal to root a into u by, so root a square is a, right, so a u square minus a z square whole power 1 by 2. Now this I can write this term to be this du. Now what will be my du dz? So if cross multiply this, we will have dz a in, I need to bring u and u to one side, dz to another side. So a into u square, a into z square whole power 1 by 2 is equal to root a into du into z. So this means du by dz is equal to du by dz is equal to square root of, I can take square root of, now if I take a power 1 by 2 outside, I can write this term to be a power 1 by 2. I am taking a power 1 by 2 outside, so we have square root of u square minus z square, here we have root a, right, root a into z. So I'm moving this term to here, this dz to that side, so I can cancel this term and this term. So what we have is du by dz is equal to square root of u square minus z square divided by z, u square minus z square divided by z. Now you need to solve this is a ODE, right, you need to solve this ODE to get the answer. So since ODE we haven't solved, you just have to follow this method. So I can write this term to be du by dz is equal to square root of u by z whole square minus 1. I can write this term to be like this, right, when you expand this we get that answer, you can verify that. Now this is a homogeneous equation, right, so homogeneous PDE. So in PDE we have 4 methods, one is by separable, one is by the one we have solved using a integrating factor, and third is homogeneous, right. In homogeneous, this you studied in 12th standard. You have to make, you will make one substitution like put u is equal to bz, put u is equal to bz. You become, from this transformation you will find the solution. Put u is equal to bz. So what will be my du by dz? Du by dz will be, so you just apply u by v here. So we have v, z, derivative of z is 1, z into dv by dz, right, dv by dz. So therefore du by dz is equal to, now we can compare this equation and this equation because both the LHS are same. So if I equate this term to that side, so from here I can write u by z is equal to b, right. So this equation now will be b plus z into dv by dz is equal to, so in place of this I can write this term to be b square minus 1 because b is u by z, b is u by z. Now we have to bring z to one side, b to another side. So if I do that, we will have, so first I will take b to that side, so we will have z into dv by dz is equal to square root of b square minus 1 minus b. Now if I take dz to that side, so we will have into dz. Now we will collect dv to one side, dz to another side. So we will have, if I bring dz to this side, we will have dz by z, and if I will bring this term to here, we will have dv divided by square root of b square minus 1 minus b, right. Yes. Now I need to integrate this. Before integrating, we need to rationalize this because we have 1 by square root of v square minus 1 minus b. Now we take conjugate. What is the conjugate for this? Square root of v square minus 1 plus v, right? If you take conjugate on both sides, you will get this answer. So dz by z is equal to minus v square minus 1 whole power 1 by 2 plus b, right? When you do this, you will get this answer. So conjugate is square v square minus 1 whole power 1 by 2 plus v is the conjugate. Now if I multiply here, we will have a square minus b square formula. So we have only left with minus 1. So that minus here, right? So take conjugate v square minus 1 whole power 1 by 2 plus v. You have to multiply numerator, that is the term here. In denominator, we have this term into plus term. So a minus b, a plus b. So v square minus 1, this root will get cancelled. So we have v square minus 1 minus v square. So v square will get cancelled. So we have minus 1 only in denominator. In denominator we will have only minus 1. So that minus I have bring the term to here. So we have dz by z is equal to yes. Now you need to integrate this, right? Now when I integrate this is log z. This is log z and minus integral v square minus 1 whole power 1 by 2 dv. So we have dv plus integral minus dv minus b dv. Now this is, you can apply the formula, right? Square root of x square minus 1 whole power 1 by 2. So this is log z. Now just apply the formula. This is nothing but v by 2 square root of v square minus 1 whole power 1 by 2 minus 1 by 2 log v plus v square minus 1 whole power 1 by 2. This is the formula for this entire term, and here we will have v square by 2, integral v dv is v square by 2 plus some constant. So this is the complete integral, and then you have to replace v by u by z, right? V is equal to u by z, and u is, we have already framed u to be yes, and then you have to replace u to be ax plus y by root a into z. So we have to replace v by ax plus y by root a into z here, so that this is the complete integral, right? So we will do one last problem and then we will wind off this. So we have completed Charpit's method. So you have to practice more problems, right? So this question is very big question. Also there is no chance that this can be asked in the exam, but this is asked in one time. I don't know why they are asking this big questions. So I have given all solutions to PYQ from 1992 to 2000 something. So you have to practice some more questions from the book. So last problem. This is 11th or 12th, I don't know, 11th, okay. So 2x into z square dou z by dou y whole square plus 1 is equal to z into dou z by dou x. Z into dou z by dou x, and this question is asked in, I forgot the year, 2002 I think, but I am not sure, but all the questions I have solved today, all are PYQ. So we need to solve this, right? So what I am going to do is, first I will multiply 2x, so I can write this as 2x z dou z by dou y whole square plus 2x is equal to z into dou x dou z by dou x. Now we need to simplify this. So put z dou z is equal to capital dou z, right? Capital dou z. So what this equation now be? So 2x and z dou z is dou z. So dou z by dou y, use capital Z, right? Capital Z, and this will be plus 2x, and I can write this term to be z dou z by dou x, and I can replace z dou z by dou capital Z by dou x. Now I am going to replace this by q because q is dou Z by dou y. So I am going to replace this by capital Q square 2x and capital P. So where capital Q is equal to dou Z by dou y and capital P is equal to dou capital Z by dou x. Now this is our f. Now f is 2x cube minus plus 2x minus p equal to 0. Now you need to find the auxiliary equation. So we will find auxiliary equation. So we have, so you just find auxiliary equation dp dq, this will be capital P, dp dq, because we have a substitute capital P capital Q, dz divided by dx divided by dy divided by something, right? Yes. Now we will do one more problem after this. Now you will get this term to be equal to 0. You can check that, right? So this is minus, this is fy plus q fz. Fy is 0, fz is 0. So this term will be 0. That means q is equal to a, right? So q is equal to a. Now we can find p by substituting this in equation number 1. This is our equation number 1. So substitute in 1. So 1 becomes, so 2x cube, so 2xa plus 2x minus p equal to 0. That means p is equal to, if I take 2x outside, 2x cube square, so it will be a square. So if I take 2x outside, you will have a square plus 1. This is our p. So what will be my dz? So our dz will be p dx plus q dy. So our p is 2x into a square plus 1 dx and q is nothing but a. So when I integrate this, you can take, if I integrate this will be z. So integration, so I can take a 2a square plus 1 is constant and x dx is x square by 2 and this is ay. So you can cancel 2, so that means z is equal to a square plus 1 x square plus ay is the complete integral, right? Yes. So we will do one last problem and then we will wind off. So last question, 2002. Z is equal to 1 by 2 p square plus q square plus p minus x into q minus y. This is a very important question. So I am going to give one shortcut for this, right? So just find the auxiliary equation. So the auxiliary equation will be dp divided by minus q plus z minus p and dq divided by minus p plus x minus q. I have worked out all the problems, right? It taken many hours to work out all the problems, right? So dq divided by minus p plus x minus q, dz divided by minus p into p plus q minus y. It is not that easy to work out all the problems, right? You have to imagine you have to know the time I'm doing for you, right? How many pages, how many problems you have done. So this will be minus p plus q minus y minus q into p plus q minus x is equal to dx divided by minus p plus q minus y dy divided by minus of p plus q minus x. This will be the auxiliary equation you will get, right? Yes. Now taking the first and the fourth fraction, taking first and fourth fraction. So first fraction is dp divided by minus q plus z minus p, and the fourth fraction is dx divided by minus of p plus q minus y. Both are, if I take this term, p minus p, actually this two term will get cancelled. So p plus q, we have, that is z, I don't know whether it is z or p, right? So if it is q, if it is q, if it is z here, this will be z, just change, right? So this two term will get cancelled, right? So when I do this term, you will get either x, both them will get cancelled, or you will get both the term to be equal to z. You verify that, right? You verify that. So whatever may be, so not this term, not this term, this term, right? So I think this is y or z, right? Now this two term will get cancelled, right? Yes. So you just do, I don't know whether I this y or q, this is z or y. If this is z, this is z, this is y, this is y. Anyway, this two term will get cancelled. That means dp is equal to dx. That means p is equal to x plus a. So we have found p. Now what we will do, we will find q by substituting this value in z, and then we will find dz is equal to p dx plus q dy. But I am going to find only one shortcut for you. Now when you compare second and fifth fraction, second and fifth fraction, again you can see this term and this term will get vanished. We will have dq is equal to dy. That means q is equal to y plus d. That's it, we have got that. Suppose if you have got p and q from this itself, and p and q is a function of x, y, z, a, what you can do is, you can just simply plug p is equal to x plus a and q is equal to y plus b in this. So we will have 1 by 2. In place of p, I am going to write x plus a whole square, and in place of b, I am going to write y plus b whole square, plus p minus x. So x plus a minus x, q minus y. So y plus b minus y. So this will get cancelled. So we have, this is the complete integral. Suppose if you have found p and q from here itself, then you can simply just plug p and q in that. Suppose it is not possible to find p and q from here, what you have to do is, you just have to find p, and then you have to substitute in equation 1 to find the value of q, and then you have to find dz is equal to p dx plus q dy. Right? This is a 2002 problem. This question asked in 12 marks. You can see just a 1 or 2 minutes problem. So I'll just quickly summarize the Charpit's method. Find auxiliary equation. You just find p or q, and then substitute in equation 1 to find another value. After finding p and q, substituting dz is equal to p dx plus q dy. You will get integrate that, you will get the answer. Suppose if you got the two arbitrary constants from here itself, suppose you got p and q from here itself, that does not contain p and q, you can just substitute p and q in equation number 1. That's it, right? So we have to practice more problems on Charpit's method. There are 10 more problems in textbook, so you can practice 10 problems, right? You can do any problem if you know how to integrate. That's it, right? So we'll see tomorrow. That's it. Thank you.